Hello, my students in grade 9. This is lecture 9 in mathematics, and the title of our lesson is Trigonometry in a Right Triangle. What are the objectives of this lesson? Identify trigonometry in a right triangle. Number 2, formulas of sine, cosine, and tangent. Number 3, identify the condition of sine and cosine of an acute angle. Number 4, identify two fundamental relations, sine squared x plus cosine squared x equal 1, and tangent x equals sine x over cosine x. What is trigonometry in a right triangle? The relation between the sides of a right triangle is the basis for trigonometry. So in a right triangle, there is a relation between the sides. During this year, we'll be dealing with the three trigonometric relations or formulas or ratios: the sine formula, the cosine formula, and the tangent formula. Before I start, I want you to look at this right triangle. Here is the right angle. We always know that in a right triangle, it's very important to specify the side, which is the hypotenuse. Always the hypotenuse is the side opposite to the right angle. So if this is the right angle, the side or the line opposite to it is this. So this is the hypotenuse. So before we start talking about the sine, the cosine, the tangent, it's very important to know how to specify the hypotenuse in a right triangle. Formulas. Here I have a right triangle right at this angle. Always, as I said, we should specify the hypotenuse. So this side is the hypotenuse. If I'm talking about this angle, which we gave it this symbol in math, we call it theta. So I gave it a name. So this angle, I just give it a name. You can name it X, you can name it Y. They name it with the symbol theta. So if I'm talking about this angle has an opposite side and it has an adjacent side. So always take the hypotenuse away. This angle has an opposite side. Which side is opposite to it? Of course, this is the opposite side. Which side is adjacent near it or coming after it? Of course, this is the adjacent side. So this angle has an opposite and an adjacent. If I'm talking about this angle here, also this angle has an opposite. Who's the opposite of this angle? This is the opposite of this angle, and this is the adjacent of this angle. So if I'm talking about sine theta, always the sine theta is equal to the opposite over the hypotenuse. So the opposite side over the hypotenuse side. So if this is called, for example, AB, and this is called BC, so I write AB, which is the opposite, over BC, which is the hypotenuse. If I'm talking about cosine theta is the adjacent side over the hypotenuse. So if the adjacent side is AC, so then I will have AC over BC. Now, if I'm talking about the tangent theta is equal to the opposite over the adjacent. Then it is AB over AC. These are rules we should study and memorize and understand them. It's very important to specify the opposite, the adjacent, and the hypotenuse of each angle. As an exercise, we are given triangle ABC right at B. We are given here an angle 30 degrees. This is an angle 90 degrees. AB is equal to radical 3, AC is equal to 2, and BC is equal to 1. So AB equal radical 3. AB is adjacent to angle 30. And BC is the opposite to angle 30. So if I want to find sine 30, it is the opposite over the hypotenuse. So it is BC over AC, then it is 1 over 2. The cosine 30, it is the adjacent AB over the hypotenuse AC. So radical 3 over 2. Tangent 30 is the opposite BC over the adjacent AB. So 1 over radical 3. This is how we find the ratios or the relations, the trigonometric relations of any angle, sine, cosine, and tangent. If I'm talking about an acute angle, I call it alpha, for example. Acute angle means its measure is between 0 and 90 degrees. It is, for example, 20 degrees, 30 degrees, 40 degrees, 50 degrees, until 89 degrees. Always the sign of alpha is between 0 and 1. It cannot be negative. And the cosine should, its value should be, cosine alpha should be between 0 and 1. Let's talk about fundamental relations in trigonometry. For an acute angle alpha, always we can use this relation, sine squared x or sine squared alpha or sine squared y, whatever the name of the angle is, plus cosine squared x is always equal to 1. From this relation, we can say sine squared x is equal 1 minus cosine squared x, and cosine squared x is equal to 1 minus sine squared x. We can use any of these three if needed. And it's very important to know that tangent x is equal to sine x over cosine x. Let's do an exercise on these relations. I'm given sine x plus cosine x, all of its square. Is it equal to 1 plus 2 sine x cosine x? I should verify these equalities. So now we will be solving them. Let me start with the first one. So I take the first side, sine x plus cosine x, all of its square. This is remarkable identity 1. So I solve it. Sine squared x plus 2 sine x cosine x plus cosine squared x. We know that from the fundamental relations that sine squared x plus cosine squared x is equal to 1. So I can write 1 plus 2 sine x cosine x. It's verified. Cosine squared x plus 2 sine squared x, is it equal to 2 minus cosine squared x? So instead of sine x, I write 1 minus cosine squared x from the fundamental relations. I multiply it by 2, so I get 2 minus cosine squared x. I have this relation. I should verify that it's equal to 1 over sine x cosine x. Also, I use the fundamental relations and I verify it. So please practice verifying these equations are very important. Another exercise, given in a triangle ABC, right at A, cosine B is equal to radical 5 over 5. We should calculate sine B and tangent B. Of course, if we are given cosine B, to calculate sine B, we can use the fundamental relation. Sine squared B plus cosine squared B is equal to 1. So I write the fundamental relation, then I need sine squared B is equal 1 minus cosine squared B. So sine squared B is equal 1 minus, and I replace cosine B by radical 5 over 5. Then I calculate to get sine squared B is equal to 20 over 25. I need sine B. Sine B is positive or negative. So it is radical 20 over 25 or minus radical 20 over 5. Since B is an acute angle, then negative is rejected. As we said, it's always between 0 and 1, and positive is accepted. So sine B is equal to 2 radical 5 over 5. After calculating sine B, we have cosine B. So tangent B equals sine over cosine. We replace and we calculate the tangent. Now to find the angle, we use our calculator. We click shift sine 2 radical 5 over 5, then it's equal to 63.43 if we approximate it, so the angle is equal to 63 degrees. Now, if I have to calculate AB, cosine B equal adjacent over hypotenuse equal AB over AC. So we have cosine B, which is equal to radical 5 over 5 equal AB over 10, because BC is equal to 10. We cross multiply, then 5AB is equal to 10 radical 5, then AB is equal to 10 radical 5 over 5, then AB is equal to 2 radical 5 centimeter. Also from sine B, we calculate AC in the same way. These exercises are very important to practice, okay? Now, let's talk about complementary angles. What do we mean by complementary angles? We have studied before that if we have the sum of two angles equal 90 degrees, then these are called complementary angles. If we have a right triangle at A, then if we add angle alpha plus angle beta, which are on vertices B and C. So if we add this angle with this angle, their sum is 90 degrees. Why? Because 90 plus 90, the sum of angles in a triangle is 180 degrees. So alpha and beta are two complementary angles since their sum is 90 degrees. If we have such a drawing, we can use sine alpha is equal to cosine beta, and sine and cosine alpha is equal to sine beta. Tangent alpha is equal 1 over tangent beta. These are rules that can be directly used when talking about complementary angles. Now, the tangent of an angle and the equation of a line in an orthonormal system. Let's go back to the coordinate system or the orthonormal system. In an orthonormal system, x prime or x, y prime or y, if we draw the line D, which has an equation y equal ax plus b, we have learned how to draw this line. And what's alpha? Alpha is the angle that the line makes with the x-axis. So this is alpha here. Now, what should we do? We should find the value of alpha. How can we find the value of alpha? We look at the line y equal ax plus b. If a, the slope of x, is positive, as the first case says, if the slope of the line is positive, then line D is increasing. Because it's increasing, then we say tangent alpha is equal to the slope. So if I take as an example a line dy equal 4x minus 3, I drew the line to specify alpha. I want to find alpha. So what I say is, since the slope of d is equal to 4 and 4 is positive, then directly I write tangent alpha is equal to 4. I use my calculator and I click shift tangent 4, it gives me 75.96. If I approximate it, it is 76 degrees. Now, if I have a line d prime of equation y equal minus 2x plus 5, here the slope of the line is positive, here the slope of the line is negative. So in the negative case slope, I say d is decreasing and tangent alpha is equal to minus a. Then I say the slope of d prime is minus 2. Since it's negative, then tangent alpha is equal minus 2, then tangent alpha is equal to 2. I click on my calculator, shift tangent 2, it gives me 63 degrees, so I found alpha. So here to find alpha, you should use your calculators after finding the tangent of alpha. Now, suppose you are given 2 points A and B, and you should calculate to the nearest degrees the acute angle alpha that the line AB makes with the x-axis. I draw line AB. Of course, A and B are on the line. So here I don't have the equation of the line. It's enough to find the slope, because what I need is the slope of the line. So we use the rule of the slope in the orthonormal system. Slope of AB equal YB minus YA over XB minus XA. So the slope of AB is minus 1. Now I say, since the slope of AB is minus 1, it's negative, then tangent alpha is equal to 1. Using your calculator, alpha is equal shift tangent 1. So the angle here is equal to 45 degrees, as you can see. So this was our very easy lesson. The trigonometry lesson is a very easy lesson. It has only some rules that you should understand and study. Please watch this video well, as I said, and if you have any question, don't hesitate to ask me. Thank you.